We will start again with the simple statements. Simple statements must be either true or false and not both. Here are two more examples. Marlon is a rat and all rats like cheese. When we use logic, it's common to give each sentence a letter so we can use it in a more mathematical way. Let's say that the first sentence here is P and the second is Q. So P stands for the idea that Marlon is a rat, and Q stands for the idea that all rats like cheese. Now that we have two simple statements, we can make a simple argument. When we make an argument with statements, each statement is called a premise, and these lead to the conclusion of the argument. So if we have premises P and Q, like above, then what do you think the conclusion would be? Pause if you want to come up with your own attempt. But I'll tell you that if Marlon is a rat is true, and all rats like cheese is true, then we can conclude from our premises that Marlon likes cheese. We can call this R. This is almost too simple to be a real argument, but you can see the idea of connecting statements with logic to lead to conclusions. We give our statements letters so we can write the whole argument down in symbols. One common symbol to show the conclusion is the double turnstile. You can think of this as standing for the word therefore. Everything on the left is true, therefore everything on the right should also be true. This is called entailment. Let's move on to negations. As we said before, these are simple statements with a reversed truth value. So if P is Marlon is a rat, then not P will be Marlon is not a rat. And if Q is all rats like cheese, then not Q will be all rats don't like cheese. Not Q is actually ambiguous. It has two possible meanings. You could think about how, and I will tell you at the end of this video. The symbol we will use for negations is the not symbol, which is a little square hook symbol. There are other symbols for not and other logic functions too. Here is an argument that works with negations of our simple statements. We can combine not R, Marlon does not like cheese, with Q, all rats like cheese, and we can conclude that not P, Marlon is not a rat. As a quick question for you, is it also okay to combine not P with Q to get not R? Pause if you want to think about that. The answer is no, that would not work. And let's quickly see why. It all comes down to what we know from Q. Q only tells us that rats like cheese. We know Marlon isn't a rat, but there are lots of other things that do like cheese. So we know he isn't a rat, but it doesn't follow that he doesn't like cheese. Maybe Marlon is a human and he just loves cheese. The same thing would happen if we try to reverse the simple version of this argument from earlier. And it should start to show you that we have to be very careful when planning logical arguments. And we've only looked at two types of statements so far. And last of all, let me go back to not Q. All rats don't like cheese. Remember I said it had two meanings? The first is that all rats, every single rat in the universe, don't like cheese. The second possible meaning is something more like there's at least one rat which doesn't like cheese. It's not true that all of them do like it. In normal English, we would have to find a way to confirm between these two options, but logic has a way of making it clear. But that is for another video. Hi there, hope you found that interesting. Like, comment, subscribe, etc. If you prefer longer videos, you can find these lessons stitched together on our other channel just up there. But whatever you do, please keep learning something, because no matter who you are or how old you are, every day really is a school day. Bye for now.